let's go ahead and we'll get started. My name is Mandy, and I am the developer of Teach Math with Me. I do math ACT uh, prep products. I develop review products, and then I've in the past helped students get ready for the ACT. But primarily now, I am developing products to help teachers and students get ready for this test. And honestly, I do not see the chat anywhere. So if you're leaving questions or anything, saying anything, I don't see it right now. Again, this is the first time I have done a live stream on YouTube. So it's all kind of new. So tonight it might just be me working the questions and I'll figure out everything. You can drop any suggestions, that sort of thing. So let's just start off with this first question that we have here at the top. Excuse me, it says shown below a board 11 feet 8 inches long is cut into two equal parts. What is the length to the nearest inch of each part? And so, what we really want to look at with something like this is going to mainly be a conversion question. And notice we have this question, we're in feet and inches. So, number one that's going to be important for this test is you need to know the conversion from feet to inches. There are 12 inches in 1 foot. Most of the time, they do not give you that conversion. So, make sure you know that. Okay, I see the chat now. So, hello, Camden. All right, so let's take a look at this. We've got this board that is 11 feet 8 inches. And next time I do this, I'll do the font larger. Hopefully you can see enough right now to get us started. My plan is, as we're going through these questions, I'm going to show you probably a couple of ways you can work the question. And I think that's important in prep because not everybody works a question the same way. Not everybody understands math questions in the same way. So I want to give you an idea of a way that may work for you. So I've got a couple of ways to talk about this question. The first one I want to look at is when we're looking at this, let's convert this 11 feet 8 inches all into inches. When we look at our answer choices, we're in feet inches, and we're going to have to do that. But let's just start off. When we have 11 feet, using this conversion, we know that there are 12 inches in 1 foot. And so that way we can get our feet to cancel out. We're going to say 11 times 12, and that is equal to 132 inches. But don't forget, we have this 8 inches, so I'm going to add that on. That's 140 inches is the length of this board in inches. We're wanting to cut it into two equal parts, so I'm going to take the 140, divide it by 2, and that gives me 70 inches. But like we said, our answer is in feet and inches. So we've got to go back now to feet. So I would take this 70, I'm going to divide it by 12, again, this conversion, and we're going to get 5.8333, lots of repeating threes. So the question is, I could look, I know it's at least 5 feet. I can eliminate D and E, but how many inches is this 0.833? Couple of different ways. You could take 0.833 in your calculator, and since we know that there are, whoops, I got the glare, sorry, 12 inches in a foot times 0.8333, whoops, it's 9.999. Round it to 10 because that 0.833 is rounded. So this is equivalent to 10 inches. Or you could say 12 times 5. That gave you 60 inches, but we had 70, so that left us a remainder of 10 inches. So 5 feet, 10 inches is our answer. All right, so that is going to be answer choice C. Another way you could have done this, excuse me, if we take this 11 feet, so this was our first way we could have worked it, doing everything, converting it out. But let's take the 11 feet and divide that by 2. You know that's 5.5, right? And so that's 5.5 feet. That's half. We're talking about the half. And don't forget the 8 inches. If you divided that 8 by 2, that's 4 inches. But we've got to do something with this point 0.5. Again, we've got to use the conversion. We know that point 0.5 or half of 12 is 6. So that's equivalent to 5 feet 6 inches. Add that 4 where we divided the 8 by 2, and you have 5 feet 10 inches there. So again, I like to present different ways, and that way you can figure out, what works for you. Great. Good job, Camden. So, another thing, when we're working these questions, the reason I will always say working practice questions are so important. You got to know how to work the questions. But a lot of times, if you've taken the ACT before, you may have noticed sometimes you see repeat questions. They may just change numbers. So if you have a familiarity with the question, that's going to help you. But also, if they throw in a little kink, if you remember certain things, hopefully you can figure it out. So that's the biggest goal right there in working questions and working lots of them. Okay, question 2 that I've got is what is the least common denominator of the fractions 5 over 21, 1 over 12, and 3 over 7? So let's do a little review of a few things. So when we're talking about a denominator and a fraction, that is the value underneath that division bar. So like for 5 over 21, the denominator is 21. For 1/12, it's 12. 3/7, it's 7. And we're looking for the least common denominator. Sure, you can ask a question. What you got? I am a tutor. I have been a tutor for quite a few years, but I'm not a teacher. I'm actually an engineer, but I work with a lot of teachers and do ACT prep material and tutoring. So, yes. Okay. So, yeah, math is my thing. I enjoy it. So, all right, so we're looking for a least common denominator of these three fractions. And the thing, anytime you have a question and you're looking for like the greatest or the smallest or whatever, first thing I'm going to do is I'm looking at the answer choices. Most of the time, not always, they order answers from least to greatest or greatest to least, but it's usually not all mixed up. I'm not saying you'll never see it that way, but when we want to find a least common denominator, we're looking for the least value that any of these denominators can divide into a number evenly. No remainders, okay? So, what I want to do is, since I'm looking for the least, I'm going to start with 46 and I'm going to say, can I divide 21 into 46? And you're going to get, if you use your calculator, 46 divided by 21, we get a decimal number and it goes on out. So that's not even. So we already know A is eliminated. What about 84? If we try 84 divided by 21, we're going to get 4. If we do 84 divided by 12, we get 7. And 84 divided by 7 is 12. Okay. So our answer turns out to be B, 84. So sometimes you can see that and it's easy. The biggest thing is to check each one. And also, just as a little side note, it may not come into play here, but, and I didn't really check these for sure, some of these numbers may be divisible by the denominators, but since we're looking for the least, we're going to go with 84. That's the first one, the smallest one that we come up with. All right. So that one was answer choice B. Now, it's question number 3. Oops, it's a little, my camera's. Okay, question number 3, we're going to get some practice working with exponents. Let me get a little bit closer on this one. Okay, it's hard to see 4x to the third times 8x to the seventh. So we want to work these questions fast too, right? We want to get them correct, and we have most of the time people have issues with time. So the first thing whenever I'm doing this, I'm going to look at multiplying my whole numbers. The 4 times 8, and that is 32, right? 4 times 8 is 32. So I can already, oh, my camera is trying to focus. I can eliminate A, B, and C already. Let's say time is running out. That's going to be important. Then I've gone from having a 20% chance of picking the right answer down to 50%. But hopefully we're going to have plenty of time because we want to know the rule when we multiply variables of the same base. So we have x, we add the exponents. So it's going to be x to the 3 plus 7, which is x to the 10th, right? So we have 32x to the 10th, which is answer choice D. So same base variables, you add the exponent. Now what about, and that's when we're multiplying. Here's a little extra. What do we do if we are dividing variables of the same base? If I had x, whoops, can't see that, x to the 7th divided by x to the 3rd. Same base of x. How do we handle exponents that way? We're going to subtract the exponents. It would be x to the 7 minus 3, which is x to the 4th. Okay, so that's very important. Those are skills that you're more than likely going to see something where you have to use that knowledge. Okay, let me go back up for this longer worded question. Question number 4. Okay, this is a probability question. I see the word there. So sorry that my camera is trying to focus when I put the pen down. Okay, one day will be randomly selected from the 7 days in a week. Then 1 month will be randomly selected from the 12 months in a year. What is the probability that the selected day will be Wednesday and the selected month will be July? So we're looking for the probability of Wednesday and that it's July. So in statistical terms, which you really don't have to know, but it's important to know how to handle these, we have this is an example of the probability of 2 independent events. And what that means, if it's Wednesday, that has no effect on it being July, the same as if it's July, it has no effect of it being on Wednesday. So we can look at the probabilities of each of these, the probability of it being Wednesday and the probability of being it July, and we're going to multiply those together. That's by definition. And I also like to review whenever we're talking about probability, when we're doing in fractions, we usually look at a part over a whole. And the reason I want to talk about fractions is because I'm looking at my answer choices, and those answer choices are in fractions. So I'm going to come a little closer now that we've seen all the words. Okay, so let's first say the probability of it being Wednesday. We know there are 7 days in a week, and with one day being Wednesday, the probability of that is 1 over 7. And we said these being independent events, we're going to multiply the probability of it being July. There are 12 total months and 1 July. So our probability of both of these, we're going to multiply it together, and we get 1 over 84, which is answer choice A. The probability of 2 independent events. But I'm going to say it's a Wednesday in July. Okay, you're going to see probability. I can't say that it's going to be this type of question, but you really need to be familiar with working with fractions, working with decimals, and probability. Okay, I've got one more question for tonight. And this one's usually I'm going to try to put a challenge question as the last question. Okay, and usually these type of questions are going to be a more in general. It may not necessarily have a lot of numbers in it, but it's usually making a generic statement. And so we got to know what some of these things mean here. Okay, so it says if x is less than -1, which of the following best describes the general relationship between x to the fifth and x squared? So let's look at this. I'm going to come in close. When I come across one of these, and these are usually near the end of the test, not always, but I'm going to also use my answer choices to try to guide me. And what it's showing me here is they're looking for some kind of relationship, right? Is one number less than or greater than? Are they equal? Do they have a negative relationship? Do they have a inverse relation to one another? So that's kind of what we're looking at. And when I have a question that really doesn't have numbers in it, I'm going to try to use sample data to pick some numbers that would work. So this first if statement tells me what my sample data could be. So it says if x is less than -1. Now, another thing about picking sample data, I want to pick numbers that are nice to work with. It's got to be able to fit the question and be able to be a generalized statement on it. But if I can pick a 0 or a 1, something like that, I really don't like using fractions if I don't have to, or negative numbers. But look, in this case, I'm going to have to use a negative number, right? Because it's saying x is less than -1. But I want to get to the number maybe as close to -1 as I can to start with and see if that is a generalized enough statement. So I'm going to say x is equal to -2. Okay, so if x is equal to -2, let's see what x to the fifth would be. So if we plug in a -2 and raise it to the fifth power, we're going to get 2 to the fifth is 32. And what happens when we have a negative number raised to the fifth? It's going to be negative, right? Because a negative times a negative is a positive. That gives us times another negative, gives us a negative. Times a negative is a positive, and then one more negative is a negative. Okay, so we have -32. And then the other thing is x squared. So -2 squared, the 2 squared is 4, and the negative squared is a positive. So we've got a -32 and a 4. So if we look at our answer choices, how does this fit with our data? X to the fifth, so -32, how does it relate to 4? -32, x to the fifth, is less than x squared. So that's going to be answer choice F. And can we use that to apply to all numbers where x is less than -1? And we can, because in general, we want to remember that a negative number that is raised to an odd, I'm going to say do it like that. When it's raised to an odd power, your result is a negative number, right? Put over there. But a negative number that is raised to a positive is going to result in a positive number. Okay? So we're always going to have this type of relationship when we have this if statement there. Now, why is that important? Remember at the very beginning, I was saying how sometimes they repeat questions and other times they do different things. For this question, their main thing I think that they're testing is that you know this. So if you know this, when you run across a different question that maybe they use some other application, some other wording, if you come back and think, okay, they're trying to do something with these odd and even exponents, let me see if I apply this. Does it help me? So that's the kind of thing we want to be thinking about as we're working practice problems and doing prep work, that we're not just coming up with tricks to do things. We're actually trying to learn it and figure it out. And that way, when we get in there to the test, you got it. You can just use the different skills that you've learned and work through these questions. So, those are the 5 questions that I picked for tonight. And I'm planning now, next week, of course, being Thanksgiving, I'm going to skip next week, then hopefully pick up the first 2 weeks in December and do something similar to this. If you have any questions or any specific topics that you would like for me to do some questions on, be sure and just let me know. You can put that information below, or um, send me a message through my YouTube stuff. Um, and I've got a lot of different videos on YouTube working through different questions, talking about different topics of the ACT. And so go out there and take a look at that. But I hope some of that has helped. Are you taking the ACT soon? Got a test coming up. I know there's one the second weekend in December. Some of our students just got back scores from October. We had some really good results, some that are really happy. So, doing prep work can help. Having your goals and figuring out what you want to make and doing that. I mainly focus on math. That's mainly, I do maybe some science, a little bit of science here and there. But we know that ACT is fixing to change up some stuff with science next year. So we're kind of waiting to see on that. But I think math, if anything, math is going to be the same with respect to the scope of the questions. Maybe not quite as many questions, and your timing's going to change. So, but we'll see when we get to that. So that's all I have for tonight. Thanks so much for joining me, and I will be back here in 2 weeks. Thanks a lot.